Industrial pineapple processing begins in the field. Pineapples are cultivated in tropical climates where heat and rainfall allow sugars and acids to develop together. Industrial varieties are selected for high juice yield, firm flesh, and predictable ripening, qualities required for both canned products and juice production. A pineapple structure allows multiple industrial uses. Firm, intact flesh can be sliced into precise shapes for canning. Flesh that lacks geometric perfection still contains full sugar content and flavor, making it ideal for juice extraction. Ripeness determines processing decisions. Sugar concentration, acidity, and firmness are measured before production begins. Pineapples with ideal shape are directed toward canning, while irregular fruit is routed toward juice to maximize yield and minimize waste. Industrial processing is built around yield. By separating edible flesh from inedible material early, factories direct every usable portion toward a product stream. This approach supports both canning and juice production while reducing waste. Pineapples are harvested manually to protect the fruit from impact damage. A clean cut at the stem preserves flesh integrity and reduces bruising. Mechanical harvesting would increase speed, but risks internal damage that compromises both canning quality and juice yield. Crown trimming reduces bulk during transport and prevents puncturing neighboring fruit. Clean trimming minimizes exposed tissue, slowing enzymatic reactions that begin immediately after harvest. Container choice affects fruit quality. Crates reduce pressure and bruising but require more handling. Bulk bends move higher volumes quickly but increase contact stress. Factories balance speed against quality loss depending on distance and timing. Once loaded, pineapples must reach the factory quickly. Transport time directly affects quality, as biological processes continue even after harvest. After harvest, enzymes begin breaking down pineapple tissue. Delays reduce firmness for canning and alter flavor for juice. Fast logistics preserve structure, sugar balance, and overall yield across both product lines. At the factory, pineapples enter a controlled intake environment. From this point forward, agricultural handling ends and food-grade processing begins. Careful unloading prevents impact damage that could introduce contamination or reduce product quality. Visual inspection removes fruit that cannot be safely processed. Mold, deep bruising, or over-ripeness indicate microbial risk or structural breakdown. Rejecting compromised pineapples early protects every downstream step. Rejection systems physically separate unacceptable fruit. This prevents cross-contamination and ensures only structurally sound pineapples proceed further into processing. Washing removes field debris and surface microbes. Multiple stages ensure thorough cleaning before any cutting or peeling occurs. Filtered water is reused under controlled conditions. Filtration removes debris while maintaining hygiene standards, reducing water consumption without compromising safety. After washing, pineapples are staged in clean conditions. From this point onward, every process step must maintain food safety as fruit moves toward mechanical transformation. Crown removal is the final shared operation for all pineapples. Automated cutting ensures consistent removal without damaging the fruit body. From this point forward, processing decisions become irreversible. Peeling removes the inedible outer layer while preserving maximum flesh. Precision is critical. Over-peeling reduces yield. Under-peeling risks contamination. The pineapple core is denser and more fibrous than surrounding flesh. Its presence influences how the fruit will be processed. This structural difference determines whether the pineapple is suitable for canning or better utilized for juice extraction. This is the split point. Pineapples with ideal geometry move toward canning, where shape and firmness matter. Irregular fruit, still rich in sugar and flavor, is routed toward juice extraction. From this point forward, the two processing lines operate independently. Once separated, the product streams never mix. Equipment, containers, and processes remain dedicated to each output. This separation ensures efficiency, safety, and consistent product quality. Juice extraction begins by reducing the pineapple's physical structure. Whole flesh is too dense for efficient liquid release. Crushing breaks the rigid cellular framework, increasing surface area and freeing juice trapped inside plant cells. This step is mechanical, not thermal, preserving aroma compounds while preparing the fruit for separation. After crushing, the pulp is gently conditioned inside a closed system. Slow agitation allows natural enzymes already present in the pineapple to soften cell walls without introducing air or heat. This controlled environment improves juice release while preventing oxidation, foaming, or premature separation. The conditioned pulp is then subjected to mechanical pressure. A screw press applies steady compression, forcing liquid through fine openings while retaining fibrous solids. This method balances yield and quality, extracting juice efficiently without excessive shear that could cloud the product or damage flavor. Even after pressing, small fiber fragments remain suspended in the juice. Vibrating screens remove these solids based on particle size. Early fiber separation improves texture and prevents clogging in later filtration steps, while recovered solids are diverted for controlled by-product handling. The extracted liquid is collected as raw pineapple juice. At this stage, yield is monitored continuously. Consistent flow rates and stable output indicate that crushing, conditioning, and pressing are balanced correctly. This control ensures maximum recovery of juice while maintaining uniform composition for downstream refinement. After extraction, pineapple juice still contains suspended pulp particles that affect stability and texture. Centrifugal clarification uses rotational force to separate these solids by density. Heavier particles migrate outward, while clarified juice remains closer to the center. This step improves clarity without relying on chemical additives or excessive filtration. Clarified juice then passes through fine filtration. Cartridge filters remove remaining microscopic solids that escape centrifugal separation. Maintaining stable pressure ensures consistent filtration performance. This stage refines mouthfeel while preserving dissolved sugars, acids, and aroma compounds essential to pineapple juice character. Pineapple juice varies naturally between batches. Small samples are taken to measure sugar concentration and acidity. These values define flavor balance, microbial stability, and regulatory compliance. Measurement at this stage provides the data needed to standardize the final product without altering its natural composition. To achieve uniform flavor, juice from different batches is blended. Combining lots with slightly different sugar or acidity levels produces a consistent result. Controlled blending smooths natural variation while keeping the juice 100% pineapple derived, without dilution or artificial adjustment. Once blended, key parameters are verified again. Stable readings confirm that the juice meets defined specifications for sweetness and acidity. At this point, the liquid is uniform in composition, appearance, and flow behavior, ready for thermal treatment and long-term stability. Pineapple juice is stabilized using a closed, loop heat treatment system. By keeping the liquid fully enclosed, the process prevents contamination while allowing precise control of temperature, as the juice moves continuously through the system. Heating targets naturally occurring enzymes that can destabilize juice over time. By raising temperature briefly and holding the juice in motion, enzyme activity is reduced without prolonged exposure that would degrade aroma or flavor. Time inside the system is controlled by flow rate and pipe length. Maintaining steady movement prevents overheating while ensuring sufficient exposure to heat. This balance protects flavor while achieving stability. Cooling follows immediately after heating. Rapid temperature reduction limits chemical changes in the juice while keeping the system fully enclosed from start to finish. Continuous monitoring records temperature and flow throughout the process. These records verify that thermal conditions remain consistent, ensuring safety without sacrificing the natural characteristics of pineapple juice. Freshly extracted pineapple juice naturally contains active enzymes suspended within the liquid. These enzymes originate from the fruit itself and remain present immediately after extraction. Their activity influences texture, stability, and long-term behavior of the juice if left uncontrolled. Enzyme activity is quantified using laboratory measurement tools before thermal treatment. Measuring activity levels provides a reference point, allowing processors to apply heat precisely rather than excessively. This ensures enzymes are controlled without unnecessary impact on flavor. Thermal exposure reduces enzyme activity by altering protein structure. The juice is heated briefly and held in motion, allowing temperature and time together to limit enzymatic effects while avoiding prolonged heat contact. Rapid cooling follows heating to limit chemical changes in the juice. Lowering temperature quickly helps preserve natural aroma compounds while maintaining the stability achieved during thermal treatment. After heating and cooling, the juice exhibits stable flow and appearance. Recorded process data documents the conditions applied, ensuring the product remains consistent while retaining the natural characteristics of pineapple juice. Once pineapple pieces are portioned, sealing protects the product from external contamination. Mechanical seaming creates an airtight metal seal, which is essential for maintaining product integrity during heat treatment and long-term storage. Date codes provide traceability, linking each can to its production conditions. Cartoning and palletizing stabilize the product for transport, ensuring cans remain protected from physical damage throughout distribution. Aseptic filling allows juice to be packaged without reintroducing microorganisms. Bottles are filled and sealed in a sterile environment, preserving safety while extending shelf stability. Cartons provide an alternative package format with strong light and oxygen barriers. Labeling and date coding ensure product identification, while automated packing prepares units for controlled distribution. Quality control verifies that sealed cans meet safety standards. Sampling and microbial testing detect potential contamination, ensuring canned pineapple remains safe throughout its shelf life. Juice quality is verified through chemical and microbiological checks. Measuring sugar content, acidity, and batch data ensures consistency while maintaining compliance with food safety requirements. Canned pineapple is stored at ambient temperatures. Metal cans and protective cartons form multiple barriers against moisture, light, and oxygen, allowing long-term storage without refrigeration. Juice storage depends on packaging format. Some packages remain stable at ambient temperatures, while others are held under refrigeration to maintain physical and chemical stability. Canned pineapple is per export in sealed containers. Pallet alignment and dry conditions protect the product during long-distance transport. Juice shipments are handled independently. Dedicated containers reduce handling errors and maintain traceability across international distribution routes. Canned pineapple supports large-scale food manufacturing, offering consistent portioning and extended shelf life for industrial applications. Pineapple juice supplies beverage brands and culinary markets. Its liquid form allows direct use in drinks, sauces, and prepared foods. From whole fruit to preserved forms, each product reflects a different approach to storage and distribution. Together, they illustrate how pineapple is adapted to meet global demand.